So, Assalamualaikum warahmatullahi wabarakatuh, and good day to each and everyone. So, once again, this is EE224, 225 electromagnetism for engineering. Okay, so last meeting we have already discussed the basic implementation or notation for vectors. Okay, so we have also discussed we have also discussed the so-called vector calculus. No? Um, we have already uh, discussed or introduced the concept of dot product and the cross product. No, we have also differentiated them. Okay, and we have also discussed their characteristics. Okay, so and of course we have also uh, discussed about gradient, uh, curl, curl, and divergence. No, so their different application are based on what we have discussed. No, so for the curl, not just a little review about what we have just discussed. The curl is the application of vector. The curl is the application of uh, yun, cross product and cross product of a certain gradient or del operator, cross product of a certain del operator, and the divergence is a application of dot product of a del operator with a certain function. Okay, so please take a review about that one kasi nga we are having to apply that one in a certain application. Okay, so now we will be go through differential calculus. Basically we'll be fine on how to derive a certain function and how to um, have its application. Okay, so now dito tayo sa product rule, no? So we have already discussed this one in our previous mathematics, no? So for the product rule of the differentiation, so if you have okay, so for the sum rule, if you have a function that is summed up, no? So or to take its addition, no? So we have here function f and function g, and we have to derive that one. So what we'll do is to derive that one term by term, or we have just to distribute the differentiation, no? On that addition of a function. Okay, so that is equals to df over dx plus dg over dx. So we have to derive that f and g, function f and g, individually. Okay, for multiplying a function by a constant, okay, so what we'll do is yung constant kay kuan naman siya. So as we just still, no, this is what we have learned from our previous mathematics. So you just have to factor out the constant kasi nga yung constant kay wala naman siyang derivative. So factor out natin yun siya, no? So what we'll do is to derive lang yung function na involved. Okay? And for the product rule, we have to apply the product rule. So we have kung meron tayong multiplication of two functions f, g. So if we have to derive that one, so we have f derivative of g plus g derivative of f. Okay, for the quotient naman, so quotient of two function f over g. So if you have to derive that one, so we have g multiplied by the derivation of f minus f multiplied by the derivation of g over g squared. Okay, so yan. And same for the gradient. No? Same for the gradient or del operator. So if you have a function f plus g, then if we take the partial derivative of that one, so um, we have just to distribute the del operator. Okay? Then for the divergence naman, so we have this one, this rule. Please study this one. And for the curl, we have also this one. Okay? So, and same on this rule here, if we have a constant that is multiplied by the function or a function that is multiplied by the constant, what we'll do is just to factor out that constant and take the del operator or partial derivative of that f. Okay, so same for the dot and curl. Okay, so now um, we have also here a six product rule that is very important in application of electrodynamics, so please study this one. Okay, so in a exams, no, I will let you uh, to write this, okay, important equations here, no, and in a certain paper, no, to serve as your guide, okay, para hindi na kayo mag-memorize. But see first, no, on how to apply this one. Okay, please be familiar with how to apply these equations here. Okay, and of course this one. So we have here an illustration, no, illustration or a proof, no, bakit, why is it that itong divergence, okay, ito yan siya, wait na, saan ba yun? Ito, divergence of function A that is multiplied by a constant f. Why is it equal to this one? Okay, so we have an illustration here. Okay, so um, please be familiar with that one. No, so this is very important. No, so please be familiar with that one. And for the second derivative naman, for the second derivative, so we have also this one, divergence of gradient. Okay, and curl of divergence or curl of gradient, no? Why is it that this is tinawag siya as a divergence of gradient? It's because you are about to take the divergence of the gradient of t, no? So be differentiate, no, between these two, no, two notation. It's because may mga nalilito about this one, no? So if you have a gradient operator, okay, or del operator that is applied on a certain function t, okay, so if wala siyang dot, we call this one as a gradient. Pero kung meron siyang dot, we call that one as a divergence. No? So, as what we have just discussed previously, okay, on how to take the divergence. So, ito yun siya, no? So, ito siya, tinatato siya as a divergence of gradient. So, we are taking the divergence of gradient of t. Okay, so, this is the formula, this is the notation, no, basic notation. For the curl of gradient naman, so this one, okay? So, please be familiar with that one. Then, for the gradient of divergence naman, gradient of divergence, so we have this one. Gradient of divergence, so we have this one. And for the divergence of curl, we have also this one. Okay, so we have here a derivation, no? Bakit siya naging equal to 0. And for the curl of a chord, no? So we have here curl of a curl V, no? So we have this notation here, okay? So please be familiar with this one. Anyway, no? I will let you naman to bring all the possible formulas that you have, no? That you can have in the exam, in our exam. So hindi naman siya ganun mahirap. So but rest assured that you can apply all these possible equations here in our exam. So please, no, at least be familiar with that equation. Okay. So anyway, later I will be giving you a textbook, no, regarding on this one. So please read something about this discussion here, no, because we don't have enough time to discuss that at all. So anyway, I will let you naman to ask some question about this one. So please, no. So dito tayo sa integral calculus. Okay, so we have here line, surface, and volume integrals. So for line integral, no, so we have this basic formulas here. For the line integral, we have if you have a function v, then if you're about to take its integral, so we have v dot dl, okay, from a to b. So integral of v dot dl from a to b. So if you have a function v, so and you are asked to find its line integral, so you just have to apply this equation. Okay, so later we'll be having that one. So v is a vector function and dl is the infinitesimal displacement. Okay, that infinitesimal displacement have already discussed, no, in our previous topics. No? So that is equals to dl, that dl is equals to dx x hat plus dyy hat plus dz hat, no, in xyz coordinate system. Okay, so we have already discussed that one, no. And for the integral, um, the integral is carried out along the prescribed path from point A to point B. So um, dapat, no, for you to be able to perform this integral here, you have a prescribed path, no. So dapat meron kang limit. Okay, so example, so work done by the force. So when you are asked to find the work done by the force, you will be using this equation here. So work is equals to integral of f dot dl, provided that your force, the application of force, no, nung nag-apply ka ng force is meron kang path na prescribed, no. So for example, starting from point A to point B, you are applying a force F. So in that prescribed path, no, so makukuha mo yung required na work, okay, in order to perform that doings, okay. So if the path is closed, we write this notation, no. For example, kay you are going from A to B, and initially, and after that kay you go back to point A, so that is a closed path, that is considered as a closed path. Okay, so we have here an example. So calculate the integral of a function v is equals to y squared x hat plus 2x y plus 1 y hat from point A to point B along a path 1 and 2 shown in our figure. So what is um, v dot dl? Okay, what is the value of closed path v dot dl for the loop that goes from A to B along 1 and returns to A along 2? So we have here a path along path 1, so ito yun siya, ito, and path 2 is ito, diretso. Okay, so this is point A and this is point B. Okay, so point A is located across 1 and 1 coordinate, and point B is located across 2 and 2 coordinates. No? So you are asked to find the value of path integral going from point A to point B along different path, no, by using this function here. Okay, so solution for path 1, or the path 1 consists of path I and path 2, no. So ito siya, you are going to this one, and then after that this path na naman. And then for path I, so ito yun siya. So for path I kay ang y natin kay equal to 1, so y is equals to 1, and our dl is along x-axis, no, kasi papunta sa x-axis. So dl is equals to x hat dx, and for our kuan, for the dot product of v and dl natin, so v dot dl kay we have already discussed that one on how to perform that dot product. So what we'll do is only to get the x component of the v, okay, since our dl is along dx lang, no, or along x hat lang. So ibig sabihin, if you perform the dot product, so you will just multiply the x component of v and the x component of dl. So since ang this dl naman kay purely x component, so you will just have to multiply this dx to the x component of v natin. So ito yun siya, y squared. No? So ito. So we have here y squared dx. Okay? But since we have said that y is equals to 1, then substitute the 1 here. So therefore, our dl now is equals to dx na lang. Okay? Kasi 1 squared is equals to 1, so dx na lang siya. So substitute that one in our line integral. So v dot dl, perform that from prescribed path from 1 to 2, no, from 1 to 2. So dx, okay, v dot dl natin kay dx lang as we have said here. So integral of dx kay x, then integrated from path 1 to 2, then substitute the values, that will be equals to 1. Okay? So, ibig sabihin, going from 1 to 2 across the path I, so the path integral is equals to 1 lang. Okay? Then, for path 2, going from this point here, papunta rito sa taas, so that is x is equals to 2, no? That is across x is equals to 2. And DL natin is dy y hat, no? Kasi along y path siya, pataas. And then our v dot dl is, once again, same as what we have done here. What you will do is, since yung dl natin is along y path lang siya, so ang gagamitin lang natin na component ng v natin is yung component along y. So ito, 2xy plus 1. So we will multiply this one, we will multiply that one to this dy, no? Since ang dl natin is purely dy siya. Okay? So, therefore, ang v dot dl natin is purely equal to this 2x times y plus 1 dy. But since we said that x is equals to 2, so substitute the values of x here. So, 2 times 2, that will be 4. So, therefore, our v dot dl is now equal to 4 times y plus 1 dy. So, substitute that one, no? V dot dl, substitute natin yun siya dito. Okay, so 4 times y plus 1 dy integrated from 1 to 2. So that is 4 y squared over 2 plus y evaluated from 1 to 2. So substitute the value. So that is all in all equals to 10. Okay, v dot dl for path 2 is equals to 10. Okay. So therefore, for path 1, so what we will do is only to add this one here and then 10. This 10 here. So that is equals to 11. Okay. Now for path 2 naman, path 2, this one, for path 2, this one, so what is the value of our line integral? So for path 2 is our y is equals to x, no? The equation of this path here is y is equals to x. Take note. So this is from our algebra, basic algebra. Y is equals to x. Okay? So and then our dy is equals to dx from this equation. If we derive this one, derivative of x is dy and derivative of x is dx. So that's why dy is equals to dx. Then our v dot dl is equals to, since yung kuan natin, DL natin is purely yung DL natin or infinitesimal displacement natin is purely along y and x, no? So lahat may pagbabago sa x and y natin. So that is DL natin is equals now to dx x hat plus dy y hat. Okay? So that's why ang nangyari sa v dot dl natin is y squared dx plus 2xy plus 1 dy. Okay? So, okay? So that's why in here, our v dot dl is now equal to this one. But since our y is equals to x, so para itong equation na to kay purely one variable lang, so we'll substitute this here dito sa equation na to, so para ma-reduce sa into one variable only. Okay? Then after that, ito na yung final equation natin for v dot dl. So substitute that one in this equation, okay, or in this line integral, integrated from 1 to 2. So then the result would be 10. Okay? So okay, so ibig sabihin, in going from path 2, in going from A to B along this path 2, the value of line integral is only equals to 10. Okay? Compared to those in path 1 na ang value natin kay 11. Okay? So therefore, if you the question for number 3 kay, if you will go from path A to B, and then going back to path A, what is the value of path integral? So what we will do is just to subtract the two values, okay, in going from path 1 to in going along path 1 to 2. Okay, so you'll just subtract that one. So that is 11 minus 10. So that is equals to 1. Okay. So for the surface integral naman, so this is defined by this equation, v dot dA. Okay, across the surface path, integrated from across surface path. So where v is some vector function na naman, same as what we have done in our line integral, and integral is over the surface specified by s, no? So dA is infinitesimal path area with direction perpendicular to any surface. So, ang pinagkaiba nito doon sa kuan natin kay yung direction natin doon sa line integral natin kay along the path talaga, dito kay along the path that is perpendicular to the surface. So if you have this dA here, the 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 direction of that dA is perpendicular to that area, so that's why pataas. Okay? So, ganun. So, example. So, we have here, calculate the surface integral of this function v over 5 sides excluding the bottom of the cubical box shown. So, ito. Let upward, outward, let upward and outward be the positive direction. Okay? So, we have here a cubical path or cubical surface. So, meron tayong surface dito, meron tayong surface dito, meron tayong surface doon, meron tayong surface sa taas, and meron tayong surface sa back. Okay, so what this question asks about is to find the surface integral, okay, along this surface here. Okay, now for the surface one here, papunta rito sa outward the outward the page, no, papunta rito. So, ang value ng kwan natin diyan kay x is equals to 2. That is along x is equals to 2, no? Kung imagine natin, yung plane na yan is along the x is equals to 2. Therefore, dA natin is x hat, yung direction ng dA natin kay x hat, no? Directed outward the x-axis. So, x hat, and that is composed by dy dz, no? dy dito sa kuan, ito dy to siya, tapos dz. Okay? dy and dz. So, that's why the value of our dA kay x hat dy dz. So, if we take the dot product of v dot dA, so, since yung dA natin kay along x hat, tapos yung dA, therefore, if we take the dot of v and dA, we will just use the x component of our function. So, that is 2 xz. Okay? So, therefore, the value of our v dot dA is 2xz dy dz. Okay? So, ilalagay natin yun sa integral. Okay? So, the limit is from 0 to 2, from 0 to 2. So, ito na yung final value natin. Okay? And for path 2 naman, I mean plane or surface 2. So, that is, saan ba yun? Dun sa back of this page. So, that is along x is equals to 0, no? So, kasi nasa origin siya, so x is equals to 0, yung plane na yan. So, therefore, dA natin is, ang direction ng dA na naman natin ngayon is towards the negative x-axis. So, therefore, that is negative dito. So, x hat. So, that is also at the plane of dy and dz natin. So, dy and dz. So, therefore, the value of our dA is equals to negative dy dz x hat. So, therefore, our v dot dA is equals to this one. But since we say that x is equals to 0, okay, so therefore, this one is also 0. No? Kasi 0 multiplied by z is 0, 0 multiplied by 2 is 0, then 0 multiplied by dy dz is also equal to 0. Therefore, the value of our surface integral v dot dA is equals to 0. Since itong v dot dA natin kay equals to 0 na siya. And for path 3, this, I mean, not path, no? Sorry. So, and for plane or surface area 3 dito, okay, so ang value ng surface na yan kay y is equals to 2, no? That is across the y is equals to 2. So, y is equals to 2 yun siya. So, therefore, dA is equals to dx dz y hat, no? Bakit y hat? Kasi the direction of that surface is along the y-axis, no? Positive. So, dx dz kasi dx tapos dz pataas, no? dx tapos dz pataas. So, if we take the value of v dot dA, so this is across the y-axis, no? So, therefore, we will just use the component of our v along y-axis. So, yung x plus 2 natin. Okay? So, x plus 2. So, therefore, the value of our v dot dA is the multiplication of x plus 2 and itong dux dz natin. So, x plus 2 dx dz, then we take that one in integral. Okay? So, therefore, we have this equation here. And final value 12. And so and so forth for plane, for dito sa bandang dito, and for this plane pataas. Okay? So, all in all, if we have to sum up all the surface integral across that cubical surface, no? So, that is all equals to 20, no? So, yun. Now, dito naman tayo sa volume integral. For the volume integral, if we have a certain function na t that is integrated across the volume v, d tau here means that it is equals to dx dy dz, no? Ito yun siya. Dx dy dz. So, yan yung d tau natin. So napansin niyo for the volume integral wala tayong dot. Bakit? Kasi for volume integral that is not a uh, the function that we are using is not a vector anymore. Okay? It's a integral. I mean it's a scalar, no? So t function t is a scalar, hindi na siya vector. Unlike for the line integral and for the volume integral, unlike for the line integral and the surface integral, na yung ginagamit natin na function kay may direction. Okay? And then yung dx, yung dA natin at saka yung dl natin is may direction din sila. Okay? For d tau natin is wala. Okay? Kasi we are talking about volume. Okay? So example, calculate the volume integral of t is equals to xyz squared over the prism of the figure this one. Okay? So just use this integral here. So we have integral t d tau. So substitute the value of t here. So xyz squared. Tapos d tau natin kay dx dy dz as we have just said here. D tau is dx dy dz. Then integrated that one. A triple integral across that. So we have here okay. So for the dx, that is integrated from 0 to 1. Okay. No, from 0 to y or 1 minus y, ito yun siya. Okay. It's because if we take a look on the xy plane, ito yung itsura niya, no? Then itong graph na to rito is equals itong graph na to nito is suggested by this equation. So that's why in here sa along x natin, we take a limit of from 0 to x, which is from 0 to 1 minus y. Okay, so ito yun siya. Then for y naman, so that is only from 0 to 1. Okay, then for z, that is from 0 to 3 kasi from 0 to 3. Okay, so same, no? These are just very simple integration. Okay, so individually, so then after that, you will now find the value equals to 3 over 8, no? Okay, so final value of this one is 3 over 8. So hindi ko lang nalagay dito. Okay, so that is 9 over 1 over 24, so that is equals to 3 over 8. Okay? So now if you have any question regarding this discussion, kindly ask it to me right away para wala tayong problema. Okay, so these are very important method on how to deal with the electromagnetism. Okay, so kindly ask it to me right away. So I think that's all. That's conclude our discussion this week. So assalamu alaikum wa rahmatullahi wa barakatuh.